In general, atoms tend to gain stability either by losing or gaining electrons or by sharing electrons. Simply put, atoms form bonds in order to become more stable. For the majority of atoms, this means obtaining a full outer shell of electrons. An atom's outer shell of electrons is known as its valence shell. These valence shells typically require 8 electrons, except for hydrogen, which requires 2 valence electrons to fill its outer shell of electrons up completely. This gives them the electron configuration of the noble gas closest to them in the periodic table. Achieving a full valence shell puts the atom in a lower, more stable energy state, which is known as the octet rule.
The octet rule says the majority of atoms tend to gain, lose, or share electrons until they have 8 electrons in the valence shell. This gives them the configuration of a noble gas.
To gain stability, some atoms tend to gain or lose electrons. This is also known as ionic bond. Ionic bonds form between 2 or more atoms, usually non-metal and metal atoms, by the transfer of 1 or more electrons between atoms. Electron transfer produces negative ions called anions and positive ions called cations. These ions attract each other. Examples of ionic bonds are sodium chloride (NaCl) and sodium bromide (NaBr).
Other atoms gain stability by sharing electrons with other atoms, also known as a covalent bond. A covalent bond is a bond where 2 or more atoms share electrons. The sharing of atoms helps complete the outer shell of both atoms. For example, oxygen has 6 valence electrons. It can form a covalent bond with 2 hydrogen atoms. Each of has 1 valence electron, and this gives us H2O, which is a water molecule.
In conclusion, atoms tend to gain stability by gaining or losing or sharing electrons, which gives them the configuration of a noble gas, and this defines the octet rule.